starting with you, we're here to talk about semiconductors, energy, geopolitics. Can you give us a sense of the potential scale of the problem for the world's data centers as we see the rise of more complex AI workloads? And what is ARM doing to address that problem?
Firstly, Peter, I'm super excited to be here. I think it's an amazing time to be in semiconductors when you look at the amount of innovation that's taking place, and in particular, when you think about the promise that AI is bringing and the promise that the AI will bring. When I look at the audience, I'm so pleased that some of you are here to sort of listen to this really important discussion. And so I think from the plane that I got on yesterday into the conversations that have been taking place, Peter, here, it is clear to me that AI, it's not just a future thing, it is a present reality. When you think about what is taking place in the data center in particular, when you look at the explosion that is taking place in large language models, when you look at the use cases from automotive, use cases to health, use cases to education, it is clear that AI, as pervasive as it is driving an insatiable demand for power, right, and power efficiency. And so when you look at all the investments that's taking place, you look at how this industry is getting ready to sort of move forward with the investment, it, I think, is so important that we think about the power demands. Data centers today, Peter, when you look at a data center today, you know, we're told about the fact that 460 terawatts of power is what it takes on an annual basis to run a data center. To put that into a context that I think you'll appreciate, that's the equivalent of the power energy that is needed for Germany. So data center usage at 460 terabytes is equivalent to the size of Germany's power demands. And so I think it's really important that we come together as an industry, we come together to think through how do we solve that power energy issue. I can talk a lot more about what ARM is doing. Do you want me to do that now or later on?
Yeah, 30 seconds,
briefly.
Please.
So,
yeah.
Look, you know, we realize that power efficiency is critical. And since the formation of ARM in the 1990s, power or energy efficiency has been part of our DNA. And so the way that we solve the power problem is making sure that our architectures, our systems and solutions are power efficient. And so just a couple of statistics for those of you who like statistics. So ARM has been working with the AI hyperscalers, and they've all deployed solutions based on energy efficient ARM Neoverse solutions. So you look at Google, for example, and what Google have been able to demonstrate with their latest CPU based on ARM is for the same, essentially, so when you compare an ARM system to the, I'm going to just say, the alternative architecture, right, 50% performance improvement, 60% energy efficiency, right? That's Google. Microsoft, again, similar kind of improvements, 40% more power efficiency relative to the competing architecture. And let me just finish with my favorite friends at AWS. What they've been able to do is fix the power, but look at what can you do fix the performance, what can you do from a power efficiency perspective. And so, you know, they've been able to demonstrate that with the ARM architecture, you can essentially deliver a 60% energy saving by deploying on ARM. And so the reality of AI is real, but as an industry, we need to work collectively together to solve the energy problem, which is also a real problem.
Certainly is. And Gerry, coming to you, given Seagate Technology's central role in data storage around the world, what are the sort of broader implications for storage and chip manufacturing of the power issue that Will's just sort of eloquently outlined?
Well, Peter, this morning in preparation for today, I checked with our colleagues at IDC, International Data Corporation, to look for some statistics. And much like Will says, we're not on the cusp of something. We're right in the middle of something. That the projected amount of data to be generated will triple in the next 3 years, that stat by 2030, the Chinese GDP will be supplemented by more than 20% through using AI, and the States something like 15%. So whether you're in chip supply, chip design, or you're in storage, you're right in the middle of it. But the world has changed. You know, I think if this was 10 years ago, everybody would be wanting to build data centers. Every government would want data centers, but it's not quite as easy as that. And the reason for that is geopolitics. It's a very different world than it was in the predictable, globalized world of kind of the previous 30 years. And the biggest challenge is climate change. And power is a massive issue. I'll finish by saying what Seagate are doing, but I don't. Will has really articulately talked about the issue. But I think also governments and regions around the world, they're, you know, in the wake of COVID and other political pressures, they're really concerned about how secure their data is, where their data is stored, and how to protect their citizens and so on. And similarly, if you're manufacturing components, they're very concerned about supply chains. Supply chains got really affected, whether it was what happened in the Suez Canal or COVID or whatever. So there's this, what does that mean for companies like ourselves and so on? Well, we have to think more about, you know, where we locate ourselves, what we do. We are certainly attracted to countries that understand our problems, okay? Yep. So I think we're really attracted to countries and regions that understand strategy and how interrelated all these issues are. There's other distractions. There's a huge global stimulus in the States for semiconductors, which, you know, the technology we use is to build our recording heads is very akin to semiconductors. So it's very distractive. So I think for us, we have to find the right place to grow a business. And unfortunately, we're both growing businesses on these islands. And I think that speaks to some of the positivities.
Sure. And on the subject of strategy, let's talk a bit about the UK's semiconductor strategy outlined almost exactly a year ago. I'll ask this question to both of you, but Will, where are the collaboration opportunities for the UK and Ireland, and what impact can that have on the world stage?
Yeah, so firstly, I mean, I'm a product of UK education. You know, I went to university at Sheffield University. Look, I mean, the UK is the heartland and the heartbeat for innovation from a semiconductor perspective. I think that the current UK government are doing the right things with the National Semiconductor Initiative that's been kicked off. And the way to sort of solve these technological problems is to rely on academia, working in partnership with industry, working in partnership with governments. And so I think the UK national strategy is the right thing. But at the same time, the UK can't stand still. Ireland can't stand still. Because in the US, where I'm living, they're spending a lot of money to kind of do the same thing. China's doing exactly the same thing. And so I think all the elements are in place within the UK and Ireland to continue to push forward.
Sorry, additional question. We can never compete with the US, for example, in terms of investment. So is the academia route one that we can sort of rely on to stand out on the world stage?
Yeah,
look, so ARM in 2023, just some months ago, we've launched a education alliance, right, which essentially pulls in all the talent in the UK universities and beyond that. And so it's this idea of relying on academic research, right, relying on the innovation and the creativity that's taking place at the universities, but finding a pathway and a bridge to link that into industry backed by government. So I think the UK has the right formula.
Yeah, exciting times. Gerry, coming to you, same question, and perhaps a bit about Ireland policy and what
yeah, I'll start with the UK semiconductor side. We're based in Derry in Northern Ireland, so we've been talking a lot to the UK government recently. I think the UK is doing some things well, and one of them is it's really looking at its assets. I mean, obviously design is a big asset, but its assets are kind of disparate and all over the place, but it's looking at where it potentially could be world-class in 5 to 10 years. And it's avoiding the temptation to compete with the leading node fabs in terms of manufacture. I think that's sensible, and I agree that the triple helix is key. Industry, government, and academia. I would stress that industry is not all FDI, that a real good, innovative, and incubator sort of ecosystem is very important. I believe we have that. We have it in Ireland, and we have it in the UK. I would add, I'd say maybe triple helix isn't enough. I think we probably need a quadruple helix. We need to bring society with us. So instead of that debate about, power usage and data centers and climate change, I mean, we need these high-performance compute. We need data centers to solve our problems, including climate change. So we have to work together, and we have to bring society along.
How do we do that?
It's obviously partnership with government people talking together. I think in these islands, right, I think we have a lot of assets, and we have to explain them to people. Like our temperature, for example, right? It's temperate climate, and so much of the energy in data centers is spent on cooling. We have renewables. We have a huge potential in renewables and offshore. But I think the problem with renewables that's what people think about, right? But with data centers and with AI, if you can reduce the power inputs, and that's what we're doing. We're in Northern Ireland, for example, our technology, if we storage is stuck areal density at somewhere between 20 to 25 terabyte per drive, or 2.5 terabyte per disk. Our Mosaic technology you just talked about, which we're qualifying now, when we start selling it to globally, that has the ability to reduce power consumption in the data center by 45%, and space by 40%. That helps planners as well. So explaining these advantages, explaining what we have and all the potential, natural and designed, and I think that's what we do, how we bring society along with us.
It's a big opportunity, but also a big challenge, I think, to bring the world along with us. Will, back to you. I want to talk about skills in the industry you both work in. Interested in your view, living in the US, but from the UK. Is there a skills shortage that you experience, and how can government and industry work together to solve that shortage?
Yeah, so Peter, that's a great problem. We've talked about the opportunity ahead for AI in particular to make the impact that it needs. We've talked about the power challenge. The other interesting area is the skills gap, and it's one that it's not confined to the island, not confined to the UK, not confined to the US. It's a global problem, a global challenge. And so, again, the thing I'm really passionate about is the fact that I love working for a company that, when it sees problems, goes hard at it to solve it. And we don't believe in trying to solve it by ourselves. We've got this huge platform of about 1,000 partners, and as a consequence of that, it puts us in this ideal position where we can try and solve these issues. And the skills gap is a reality. And if industry doesn't come together, again, with academia, because industry can identify where the skills gaps exist, but it's in concert with academia, it's in concert with governments, that we can solve the problem around semiconductors.
Yeah.
I've got my own son's 22, and I had to cajole him into taking STEM seriously, because it's like, Dad, I mean, the failure rate's high, it's a difficult subject, but what we need to do is not only make STEM attractive, but we also got to reskill the existing workforce, right? Because it's about design, it's about fabrication, it's about making sure all of those come together and can come together in a way that's meaningful. As I said, it's not just a UK problem. And ARM, just to finish off, what we've decided to do is not just to talk about it, but to try to address the problem. And again, so we've launched yet another initiative where we're working with some great universities in the UK, we're working with the UK government, we're working with some of the global hyperscalers which are here in Ireland, but we'd love to try to get a broader participation from universities in Ireland. And so if you represent a university in Ireland, seek me out or seek anybody out at ARM, and we'd love to try to get you involved, because that skill gap is real, and it's something that we need to focus on as an industry, as well as pulling in academia and pulling in governments.
And very briefly, Will, do you see progress being made?
Slowly. I think we have 6 or 7 UK institutions, the government's backing it, India's on board, the US is on board, but it's only the beginning of things to come. More work's needed.
Certainly true. And Gerry, coming to you, in your conversations with government, is there an understanding of the problem, and what's your sense of whether we're moving in the right direction?
I think there's definitely an understanding, whether the action matches to understand, but I think it's bigger than just there's a skills gap in UK and Ireland. There's a global skills gap, particularly in the West with all the stimulus that's there. So there is definitely, I believe, with the rate of change and the impact of AI, there's a build it and they will come.
Yeah.
And the range of skills you need for semiconductors, it's very, very broad, like it's material scientists, it's physicists, but then you need the people who can use the advanced manufacturing tools to make it happen. I know certainly doctoral training centres are very important. We wouldn't be where we are without the support of universities, particularly in Northern Ireland, and from Kindlon and Cork, who best in class have been magnificent friends to us. I think, so I agree with everything Will says, but I think there's an opportunity here. Ireland jumped from an agricultural economy to a post-industrial economy. I think there's a real chance in disadvantaged areas, say like the west of Northern Ireland and the northwest of the Republic of Ireland, to build universities, to build accelerators in emerging technologies, and it's a chance to level up. It's a once-in-a-lifetime chance, I think, to level up. The difficulty with areas like that, they always look at what somebody else and says, that's what I want. But we have to show them that this isn't anywhere else, somewhere else. So I think there's a real opportunity to level up, and for regions like Northern Ireland and the northwest of Ireland, with the quality universities that, these islands have really, really good university. We probably could be better at productizing it.
Yep.
So teach us how to productize it,
Yeah, I think that's a very fair point. We do not have long left, so I will ask you both for a very brief answer. Given how sort of central to the future of the world this topic is, could you each outline one theme or issue in semiconductors to look out for over the next year or so? What's going to be the sort of...
Pete, we're already talking about it. AI is on a collision course with energy. It really is. And the way that we solve that is through energy-efficient solutions. I think we're making the right steps from an ARM perspective. We need partnerships. We need to think about the whole problem, not just the compute portion, but the whole rack, the whole system. Throwing more data centers at the problem is not the way you solve it. Is deploying the resources that you have in an efficient way, right?
Yeah, throwing more data centers at the problem is a good headline.
I absolutely agree with Will. I'd add one thing to it. I think what's going to happen in the next year is a theme is going to be urgency bordering on panic, right? I think AI, the storage issues, the power issues are going to hit us like a train. So the country, the company, the region that's agile and nimble and can bring the triple helix together to bring society along with it. That's the company and the region that'll do well.
Excellent. Well, thank you both for a great discussion, and thanks for listening.
Thank you.